Welcome back to Nick's Algebraics. Today I'm going to talk about how to solve equations with variables on both sides. So our first problem is 10 minus 4x equals negative 9x. So first what I would do is I would collect all the terms with variables on one side. So to do that, let's get rid of the negative 4x. We're going to add 4x to both sides. So that's going to cancel out, and you're going to be left with 10 equals negative 9x plus 4x. And we know that negative 9x plus 4x is negative 5x. So what we did is put all the variables on one side of the equation. So now we could solve it like a regular one-step equation by dividing by negative 5 on both sides. So you're left with x equals 10 over negative 5, which is negative 2. And now let's check our work by plugging it back in. So 10 minus 4 times negative 2, because x equals negative 2, equals negative 9 times negative 2. 4 times negative 2 is negative 8, and 10 minus negative 8, that's the same thing as 10 plus 8, is 18. And that equals negative 9 times negative 2, and the negatives would cancel out, so that equals 18, which is true, so that means our solution is right. Here's another example. 2 plus 5k equals 3k minus 6. So there are many different ways to approach this. You could get rid of the constants first, or you could get rid of the variables first. I will get rid of the variables first. So I would subtract 3k on both sides. So that would get rid of the variables on the right. And on the left, you'll be left with 2 plus 5k minus 3k, which is 2k, equals negative 6. And now we have a regular two-step equation. So we're going to subtract 2 on both sides to get rid of the addition of 2. So you're going to be left with 2k equals negative 6 minus 2, which is negative 8. And to cancel out the multiplication of 2, we're going to divide by 2. So you're left with k equals negative 8 over 2, which is negative 4. And you could check your solution, and you'll see that it works. So now let's do it with grouping symbols. So first what we're going to do is let's simplify both sides of the equation by distributing. So let's distribute the 6. So 6 times 5m minus 6 times 3. And on the right, we're going to distribute the 1/3. So that's going to equal 1/3 times 24m plus 1/3 times 12. So 6 times 5m, that's 30m. And 6 times 3 is 18. And 1/3 times 24m, that's 8m. And 1/3 times 12 is 4. So now let's get rid of the terms with the variable. So let's subtract 8m on both sides. So 30m minus 8m is 22m. Minus 18 equals 4. So now to get rid of negative 18, we're going to add 18 to both sides. And you'll be left with 22m equals 4 plus 18, which is 22. And if you divide by 22 on both sides, you'll be left with m equals 1. And if you check your solution, you'll see that it's right. Now, some equations may have no solution. That means that there's no value of the variable that will result in a true equation. And some equations are true for all values of the variables. So that's called an identity. So an identity is an equation that is true for all values of the variable. So let's do another example. So first, let's simplify the right side of the equation by distributing the 3. So we have 3 times 5x minus 3 times 4 minus 10x. And that equals 5x plus 5. So 3 times 5x equals 15x. And 3 times 4 is 12. And we're subtracting 10x. So we could combine these two terms together because they're like terms. So 15x minus 10x, that's 5x, minus the 12 equals 5x plus 5. So now let's get rid of the variable terms. So we're going to subtract 5x from both sides. And you'll be left with 5 equals negative 12. So the issue with that is that that's false. So that means that this equation has no solution. And the symbol that represents no solution is this little sign here. Let's do another example. So first we're going to distribute. So that's going to equal 3 times 2b minus 3 times 1 minus 7 equals 6b minus 10. So 3 times 2b is 6b, and 3 times 1 equals 3. And now we could combine the negative 3 minus 7, so that's going to be negative 10. And now we can get rid of the variable term, so we can subtract 6b from both sides. So we're left with negative 10 equals negative 10, which is true. So since the expressions on each side of the equation are the same, then that means this equation is an identity, which means that it has infinitely many solutions. All real numbers are the solution of an identity. So an identity is really an equation that shows a number or an expression is equal to itself, because a step ago it said 6b minus 10 equals 6b minus 10. So there are infinitely many solutions. No matter what I plug in for b, it's going to work out. So here's a word problem. Find the value of x so that the figures have the same area. So we know that the area of a rectangle is length times width. So we're going to multiply the sides together. So the area of this figure here is 10x, because you're multiplying the sides together. And the area of this figure here is going to be 6 times x plus 3, because the length of this side here is x plus 3. And we want the figures to have the same area, so they're going to be equal. So to solve this, let's distribute the 6. So that's going to equal 6x plus 6 times 3, which is 18. And now we could get rid of the variable terms, so we're going to subtract 6x from both sides. And 10x minus 6x is 4x, and that equals 18. And we're going to divide by 4 on each side, so you're left with x equals 18 over 4, which equals 4.5. And let's check to see if this is right. So since we know that this side length is 4.5 centimeters, the area of this would be 4.5 times 10, which is 45 square centimeters. And now that we know that this is 4.5, we can add it to 3, so that means this side length is 4.5 plus 3, which is 7.5 centimeters. And when you multiply those together, you get that the area is 45 square centimeters. So they're equal, so our solution is correct. So here's our last problem. A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 4.83 kilometers per hour faster downstream due to the current. How far does the boat travel upstream? So we know that this boat is going upstream and it takes 4 hours. And then it's returning downstream, but it's taking only 2.8 hours because it's going faster now due to the current. And we need to find the distance the boat traveled upstream. And we know that the distance upstream equals the distance downstream because it's just returning back. It's the same distance. What we know about distance is that using the distance formula, we know that distance equals rate times time. So instead of d, we're going to substitute rate times time upstream equals the rate times time downstream. We don't know the rate upstream, but we do know the time. It was 4 hours. So instead of t, we're going to substitute 4. And for downstream, we know that the time is 2.8 hours. And we don't know the rate, but we do know that the rate is 4.83 kilometers per hour faster downstream. So it's the upstream rate plus 4.83. Now we can solve this. So first, let's distribute the 2.8. So that equals 2.8 r plus 4.83 times 2.8. So 4.83 times 2.8 equals 13.524. So now we can get rid of the variable terms. So we're going to subtract 2.8r from both sides. So 4 minus 2.8 equals 1.2r, and that equals 13.524. And if you divide by 1.2 on both sides, you'll get that the rate equals 11.27 kilometers per hour. But we're not done because it's not asking for the rate, it's asking for how far the boat traveled upstream. And that means we're trying to find the distance. So we know that distance equals rate times time. And we know now that the rate is 11.27 kilometers per hour. And we know that the time it took to go upstream is 4 hours. So we're going to multiply that by 4 hours. So hours is going to cancel out, and you're left with kilometers like we wanted. So 11.27 times 4 equals 45.08 kilometers. So now let's check to see if our answer is reasonable. We found out that the rate equals 11.27 kilometers per hour. And using that information, we figured out that the distance it took to go upstream equals 45.08 kilometers. And we also know that the distance downstream should also be 45.08 kilometers because it's the same distance, it's just returning back. So let's find the distance downstream, and if it's the same number, then we know we did it right. So we know that the rate downstream is 4.83 kilometers per hour faster because of the current. So let's add 4.83 to this. And that's going to equal 16.1 kilometers per hour. And we know that the time is 2.8 hours downstream. So if we multiply the rate by the time, which is 2.8 hours, we should get the same distance. So hours would cancel out, and 2.8 times 16.1 is 45.08 kilometers. So you get the same distance upstream and downstream. So our solution is reasonable. So don't forget to subscribe, like the video, turn on notifications, and comment down below. I'll post a worksheet with the solutions, and I'll see you later.